Okay, on notes 2-1, we're going to be looking at laws of logarithms. So we just went over logarithms last unit. Remember, the inverse of an exponential is a logarithm. Okay, so we're going to be looking at the laws, which is very similar to the laws of exponents. Okay, all right, so we're going to have our base, b. So b is your base of your logarithmic function. B has to be greater than 0 but not equal to 1. Also, your m and n's on these examples must be positive numbers or variables, so they can't be any negatives. All right, so law 1 states that if you have a log and you're multiplying m times n, you can expand that into two different logs by breaking the m and n up, and then you're just adding those together. So when you multiply, you add. Very similar to laws of exponents. When you multiply, you add. Okay, so number 2, when you're dividing on a log, you can expand it by subtracting. Same thing on laws of exponents. When you divide, you subtract the exponents. And then law 3 states that if we have an exponent, we can rewrite that as a coefficient in front of that log term. Okay? All right, so example 1, we're going to be using the laws of logarithms to expand the following expressions. When it says expand, it means you want more than one log in your answer. So you're expanding it into multiple logs. Our base will never change. Just like on laws of exponents, our bases never change. So notice we have a 5, we have an A, and we have a B. So you're multiplying all three of those together. So if you look back up at the top, when you're multiplying, you can expand it by adding them. So my base will not change, so log base 2, I'll put of 5, plus log base 2 of A, plus log base 2 of B. So all we did was we expanded those logs. We were multiplying 5 times A times B, so we can rewrite that as the log base 2 of 5, plus log base 2 of A, plus log base 2 of B. Okay. All right, example 2. Notice that we are dividing, so we can expand it by subtracting. So log base 5 of the top, which is 8, minus log base 5 of the denominator, which is x. So those are equal. 3, we're multiplying 6 times x squared times y cubed. So we're going to be adding those together. So log base 2 of 6 plus log base 2 of x squared plus log base 2 of y cubed. Now, if you have any exponents, you would need to go another step. Look at that law 3 up at the top. If you have an exponent, you can rewrite that as the coefficient of that log in front. So that's what I'm going to do on that squared and that cubed. So I'm going to have log base 2 of 6 plus 2 log base 2 of x plus 3 log base 2 of y. So that would be my expanded form there. Alright, so notice here that we are dividing. So we're going to break those up, the top minus the bottom. So I'm going to have log base 3 of 4a squared minus log base 3 of bc squared. Now, notice that we subtracted because we were dividing the 4a squared and the bc squared. But now we need to go another step because notice here we have a 4 times an a squared, we have a b times a c squared. So we need to add those up there. So I'm going to have log base 3 of 4 plus log base 3 of a squared minus, and since I'm subtracting all of that, I'm going to go ahead and put parentheses there, log base 3 of b plus log base 3 of c squared, because I was subtracting all of that. Now we're going to get rid of those exponents by making them coefficients in front. So you can have log base 3 of 4 plus 2 log base 3 of a minus, you can go ahead and leave that in parentheses, or you can distribute the subtraction, it doesn't really matter, log base 3 of b plus 2 log base 3 of c. So make sure on these that you are writing the correct base. Don't forget the base there. The base never changes of your log. Now we're going to look at 5. On 5, notice that there's not a base written. We talked about that last unit. If you have a log that doesn't have a base, we know that base is 10. This is called the common logarithm. Okay? Alright, so notice on this one that we have a square root. Remember when we have a square root, the exponent is 1/2. So I want you to rewrite that as a to the 5th divided by b. All of that is to the 1/2 because all of that is under the square root. So if you had had a cube root, that would be a 1/3 exponent. Okay, so now I'm going to go ahead and move that exponent in front. Alright, so now notice that I have log of a to the 5th over b. I'm dividing those, so I need to break that up by subtracting or expanding it. So 1/2 log of a to the 5th minus, I'm still taking that 1/2. So actually I'm going to go ahead and put parentheses around that. And then log of b. And then one more step, we'll move that in front. So 1/2, we have 5 log of a minus log of b. And then same thing on that previous example, you could go ahead and distribute that 1/2 or leave it as is. It's the same exact thing. So whichever form you want to put it in. So make sure anytime you have a square root, you want to rewrite that as a 1/2 exponent. Alright, so now we're going to be doing the opposite. It says to condense. So when it says to condense, you're trying to get it into 1 log. So that's all we want in our answer is 1 log. Okay? So we're doing the opposite of what we were just doing. Okay, so on number 6, notice we have a coefficient. I'm going to rewrite that as an exponent. And then notice we're adding those. So to condense, when you're adding, you're going to be multiplying them. So log base 5 of 7x cubed. And that would be my answer there. So you're doing the opposite of what we were doing. So if you're adding it to condense it into 1, you need to multiply them together. Don't forget the base. The base never changes. Okay, so let's look at 7. We are subtracting. Bases are the same. So we have log base 2 of the first one. So x divided by the second one, which is 3. Okay, so notice on 8 we have a coefficient. So I'm going to go ahead and write that as an exponent. Same on this one. So I'm subtracting, so log base 6 of m to the 1/2 over n cubed. And then remember the 1/2 means square root, so I want you to go another step with that and write square root of m over n cubed. So if you have a 1/2 exponent, go ahead and rewrite that as the square root of that term. If you have a 1/3 exponent, write it as the cube root. 1/4, write it as the 4th root. Alright, so 9, notice that we have parentheses and we have a coefficient in front. So we're going to make that exponent on both of those since they're both in parentheses there. And we're subtracting. So log base 2, we're going to divide a cubed divided by b cubed. You could have also wrote it as a divided by b and then all of that was cubed. Same answer. Alright, 10. Notice we have coefficients. Go ahead and write those as exponents. All right, so we're going to be adding it says log base 3 4 plus log base 3m cubed. We're adding those, so we're going to be multiplying them to condense. So 4m cubed. And then we're subtracting the log base 3 of n squared, so we're dividing by that n squared. So you should only have one log in your answer whenever you are condensing. Whenever you're expanding, you're having multiple logs. All right, remember we talked about how when you're using a calculator, the only log that you can plug in is a common log or a natural log. So the common log has a base of 10. Sometimes you're not going to have a base of 10. Okay, so there is called a change of base formula where you can change your base to base 10. So if you look at number 11, we actually talked about this before. We're evaluating. So we used around the world. So our base was 2. We changed it to an exponential. To what power would give us that 25? Now, there's not anything 2 to a power or a whole number that would give us 25. So this is when we would need the change of base formula in order to use the calculator and plug it in. So look back up at that formula. You're going to be taking the log. You're going to write your b as your base 10. And then we're going to take the log of x over log of the original base. So I would set number 11 up as log. I don't need to write base 10 because that's just common log of 25 over the log of your original base, which is 2. So on your calculator, there is your log button. So the log is right below x squared. So you're going to have log of 25. Divide, you have to type another log in. So don't just do log 25 divided by 2. It's log of 25 divided by log of 2. You should get a decimal, and it tells you to round to 3 decimal places, so that would equal 4.644. Okay? You could check that answer. You could do 2 and then caret. We want to raise it to that power, that decimal that we just found, so you could recall the answer. So second negative, and notice it gives you that 25. So you can check it by doing around the world and just make sure that that's correct. Okay, let's look at 12. So notice here our base is not 10. You would be doing 5 to what power? Equals 12. That's not going to give us a whole number, so we're going to use change of base formula. You're taking the log, common log of 12 over the common log of 5. So remember, it's always that m or n over that original base. So I'm going to do log of 12 divided by log of 5. 3 decimal places again, 1.544. Again, you can check it. 5 to that power should equal 12. So 5 caret to get that whole decimal there, so that way it's most accurate. Second negative. And then notice it gives you that 12. Okay, so 13. We have 0.5 to what power gives us 5. So we're going to do log of 5 over log of the original base, which was 0.5. So negative 2.322. The reason it's negative is because we have a fraction here, 0.5, okay? Again, you can check it. So 0.5 caret previous answer, and you get that 5, okay? All right, and 14. We have log base 2 what power is going to give me a negative 4? Okay? Alright, so I would take log of negative 4 over log, common log of 2. Notice it says non-real answer. Your m, we're going to write no solution there because we cannot raise 2 to any power to give us a negative number there. Okay, so remember that number there, and also your base of your log can never be a negative. So if it is that, you know automatically there's no solution to that. So this is using laws of exponents, or laws of logarithms, which is very similar to laws of exponents, to expand, condense logs, and then also change your base formula to change that base to 10, so you can actually use a calculator to evaluate it.